Hi everyone. In the last video we saw a bunch of examples where we could use factoring in order to solve trigonometric equations. In this video we're going to have to do a little bit more work before we can factor. So here are some strategies for how you might approach an equation when you can't immediately factor it. So here's an example of one that we can't immediately factor. We have sine squared x plus 3 cosine x minus 3. Now, we've already written it in terms of sine and cosine, and that didn't help us. We can't factor it because while the sine is squared, there's not another sine term. And so what I need to do first is rewrite it using just one trig function. So how am I going to do that? Well, I can use the Pythagorean identity. Remember that sine squared x is the same as 1 minus cosine squared x from the Pythagorean identity. So let's replace the sine squared x with that function, and then we'll only have cosines, and then maybe we'll be able to factor. So I have 2 times 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. I'll distribute the 2 to both of these terms, so 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Combine the 2 and the minus 3, just combining like terms. And so when I add 2 to minus 3, I get minus 1 equals 0. And now since it's equal to 0, I could change the sign of all these terms, multiply both sides of the equation by -1. I'm just going to do that because it helps when your first term is positive when you're trying to factor. So that middle term becomes minus 3 and the last becomes 1. So now this looks like an equation from the last video. I can factor it. So I'm going to separate it into two different terms, a blue term and an orange term. And those terms have to equal to 0. So then I'll have two hopefully simpler equations to solve by setting the blue equal to 0 and the orange equal to 0. So how is this going to factor? The first term and this first term have to multiply to 2 cosine squared x. So one of them has to be 2 cosine x, and the other has to just be cosine x. This term and this term have to multiply to +1, and when I do 2 cosine times this plus this times cosine, I should get minus 3. This is an indicator that I'll have to put -1 here and also -1 here, because the only way to multiply to 1 is by multiplying 1 and 1 or -1 and -1. Since the middle term is negative, I use both minus. So now I'm going to solve each of these. So first, I have 2 cosine x minus 1 equals 0, which tells me that 2 cosine x equals 1/2, or equals 1 when I bring the 1 over. So cosine x equals 1/2. Now, my solution in quadrant 1 comes from a special triangle. I have x here, adjacent is 1, hypotenuse is 2. You recognize this special triangle where the last side is √3. So that tells us that x equals pi/3. Now remember that cosine is positive in quadrant 1, but also in quadrant 4. And so I have another solution in quadrant 4, which is 2 pi minus pi/3, and that gives me 5 pi/3. I get my general solution, so this is the Q4 solution, by adding on the period times some constant. So there's my solution coming from the blue factor. To get my solution coming from the orange factor, I'll set that one equal to 0. So cosine x minus 1 equals 0, which means cosine x equals 1. So I'm looking for the points on the unit circle where the x coordinate is 1. The only such answer is x equals 0. But then to get my general solution, I have to add on multiples of 2 pi, because 2 pi, I'll be back to having cosine equal to 1. If I go 4 pi, I'll be back, 6 pi, etc. So these three represent my general solution. It's the same as what we did before with one additional step. We had to convert to a single trig function. In our next example, we still have two trig functions, but I can't convert to either sine or cosine because I can't use Pythagorean identity. I could only use the Pythagorean identity when one of these, at least one of these, was squared. So the strategy that I'll use here is to square both sides to get a quadratic. And then we'll see what that looks like and what the next step will be. So if we square both sides, the first one I have to FOIL, so the first times the first is cosine squared x. The inner will be cosine x times 1, and then I'll get outer is also cosine x times 1, so my middle term is 2 cosine x, and last is going to be 1 times 1, so that's 1. And on the other side I have sine squared x. Now, my next step, this looks a lot like this example, the one we just did, where I have sine squared terms and cosine without a squared. So I'm going to convert to all cosines, again using that sine squared x equals 1 minus cosine squared x. So I already have cosine here, I leave it. This one I leave. The 1 I leave, but sine squared gets switched to 1 minus cosine squared x. Now I'm going to combine like terms and factor. So combine / simplify and factor. So I'll bring everything over. So when I add cosine squared x to this side, now I have 2 cosine squared x. This term doesn't have anything getting added to it, so it stays the same. And I have to subtract 1, so 1 minus this 1 is going to be 0. So I don't have a constant term anymore. Now, so let me just write what I did here. I added cosine squared x to both sides. And I subtracted 1 from both sides. Okay, so now I factor. Each term has a cosine in it. So when I pull cosine x out of the first term, I get cosine x. And then what I'm left with is 2 cosine x from the first term plus 2 from the second term, and this is equal to 0. So now I get my two equations. 2 cosine x plus 2 equals 0, and cosine x equals 0. Let's deal with this one first. Cosine x is 0 whenever the x-coordinate on the unit circle is 0. So that happens here and here. I'm only looking for the solutions between 0 and 2 pi, so I just have to give these two, not the general solution. So I have x equals pi over 2 and 3 pi over 2, coming from the pink factor. Now for the blue factor, I'll divide both sides by 2, and I'm left on the left with cosine x plus 1 and 0 on the right. So now I have cosine x equals minus 1. So let's see where that happens on the unit circle. That's when my x-coordinate's -1. That only happens when x equals pi. So these are my solutions. So of all the examples we've seen so far, this is the most complicated because we had to square both sides. We did that so that we could use the Pythagorean identity to convert everything to cosines. Then we had to factor. Then we set each of our factors equal to 0, and that gave us one of the basic equations that we needed to solve by using special values of cosine and sine. So this is a really involved example. Take time to study it and see all of the different elements that we used. And this should just convince you that it's not easy to solve these equations, but if you're systematic, and you use the identities, you use lots of strategies, you try something, you'll eventually get to a solution. So good luck. We'll practice some more in class.